Greetings, everyone. Thanks for joining us today for an awesome discussion on how Kubernetes can either help your life or destroy your life. But before we kick it off, let us introduce ourselves. So my name is Marcelo. I'm the head of infrastructure modernization at Mechanical Rock, and with me today I have Nate and Nathan. So if you can introduce yourselves and let everyone know who you are, and include a 1 to 2 sentence definition of what Kubernetes is to you.
All right, well, I'm Nate Jomboy. I'm a DevOps consultant for Mechanical Rock. In terms of my relationship with Kubernetes, like most things in my life, most days I love it and sometimes I hate it. But I'm really keen to talk about why these things happen and talk about like where it's actually good.
Cool, thanks, Nate. I'm Nathan Glover, DevOps consultant with Mechanical Rock as well. I've used Kubernetes for a couple of years now. I've had mostly good days with it, quite a few bad days with it. Fallen in every rabbit hole you could probably find there. So I'm really excited to talk to you about those problems and solutions and just general Kubernetes stuff.
Cool. It sounds like Kubernetes is like a marriage, isn't it? You embark on that journey and it's like you're getting married, highs and lows.
It is a bit. Yeah, like you're not sure what you're going to get into when you start. It's really fun. I'm not going to go on with this analogy because it could get weird, but
it's all going to go downhill from there, I think, downstairs. All right.
Before we get started, I think it'd be good to ask for people who are in the chat, could you just drop down maybe a general like easiness with have you used Kubernetes before, or like do you use it day to day? Have you just sort of heard the word? Do you know nothing, absolutely nothing, and that's why you've rocked up? It'd be cool to get to sort of gauge. So if you just drop like a one word thing in the chat just to let us know, that'd be awesome.
Nice. All right, so to begin with, here's the outline of today's discussion is going to go like this. It's going to be myself starting with what questions you should be asking yourself when you're evaluating container orchestrators. Should Kubernetes be on your list? Followed by Nate, who will be deep diving into the pros and cons of Kubernetes. After which Nathan will take us through an actual case study of a Perth multinational company who Mechanical Rock helped implement Kubernetes. After which there will be a live demo of SGO and Kubernetes by Nathan, followed by a GitOps overview of how you implement a Kubernetes project using GitOps methodology way of working. And if you have any questions along the way, just submit them to the channel, to the panel, and we'll have a session at the end of that after all that, and we'll answer your questions then. So yeah, as you think of one, just submit it, and we'll go through them at the end. All right. So next, when should you consider Kubernetes as your container orchestrator? Well, it's not an easy question actually to answer, but there's a few things you should be asking yourself before choosing to use Kubernetes or the cloud's default container orchestrator. Because today we're going to talk mainly about cloud native applications and how Kubernetes can help with that or not. So if you're at the stage of evaluating containers orchestrated, you should already have visualized or documented your business logic with an idea on how large or small your container base running your application should be. Or even better, if you have a good, I guess, if you profile your applications and if you know your resource constraints, CPU, memory, and storage, that's going to help a lot in helping you manage the costs and implement some auto scaling. So the first question to ask yourself is, how complex is your workload? Is it simple, or is it a very complicated workload that you have your containers workload running on? So a simple workload will be something that's stateless with a database backend that's hosted by a managed service on the cloud or a platform as a service, and you have basic placement strategy, which means so when you deploy out your container for your application, you don't really care on what node or what virtual machine it lands on. You don't have strict constraints on memory, CPU usage, and so on. So if you have that kind of basic placement strategy or requirement, definitely stay away from Kubernetes. It's just overkill. So at that point, you'd be using the cloud platform's default container orchestrator, like AWS's ECS Fargate. In GCP, well, you've got Kubernetes, but if you have a really container requirement, then look at Cloud Run. That's essentially a service where you can just throw the container over the fence and it'll deploy it without managing any servers. So, and if you're not Azure, then yeah, use whatever they have. If you have a complex workload, you'd be having to deal with some sort of state management in your container runtimes, advanced auto scaling. So if you have some really weird business or advanced business requirements where you need to scale dynamically based on some very complex set of requirements, then Kubernetes is really helpful in that department. If you want to have the ability to deploy updates with no downtime, Kubernetes has many options or ways to do that as well as self-healing. So as things fail, they automatically heal and keep your application running, so no downtime. So that's the main difference between simple and complex. And there's obviously some middle ground there, which may be a bit, bit grey, unknown. But yeah, that's kind of how you should think about it initially when asking yourself. The second one would be the auto scaling or hybrid environments. How are you looking to scale? Again, go back to your business logic and look at what are your scaling requirements are. Horizontal and vertical auto scaling offered by Kubernetes is quite powerful, and you've also got custom ways of configuring that as well. So horizontal, for example, pod auto scaling, if your workload starts going up, it'll automatically start deploying more pods across the nodes or across the node for you based on CPU or memory metrics that you specify, based on how your application behaves. So that's something that you don't get with, you get a little bit with your default cloud platform orchestrators, but we haven't seen, the features aren't that advanced, so you can only do a small subset of that scaling component. But if you have some advanced scaling requirements, yeah, definitely look at going towards Kubernetes. Otherwise, yeah, stay away again. If you're looking to deploy Kubernetes on a hybrid environment, the main thing to consider here is you shouldn't really go Kubernetes just because you have Kubernetes on-prem. When you go to the cloud, you always have to deal with that last mile, which you don't have on-premise. So, load balancers, e-ingress, any kind of proxies, even databases or data stores. So that really kind of changes the landscape, and it's in those situations where you're better off going with the cloud platform's orchestrator, default orchestrator, instead of Kubernetes, because the integrations be a lot easier with the whole platform. So that's something you should consider when going on-prem, or hybrid, sorry. But if you have clusters everywhere, GCP, I have this Anthos GKE on-prem option, which gives you the ability to manage multiple Kubernetes clusters through a single pane of glass, and have a central console where you can do that. It's a good way to manage a mess, but yeah, it's not really the way to go, I think. But if you really want to, you have that option there. One of the other reasons, yes, one of the other reasons Kubernetes is out there and really growing, expanding, and not stopping is the way they've designed their platform. So it's highly customizable with the many integration options. So Kubernetes offers to all types of software and hardware vendors standard plugin interfaces. Like, for example, we've got the CSI, CNI, and CRI. So basically, your container storage interface, your container network interface, and your container runtime interface, which allows, if you're building your own product from scratch, and say you have your own container runtime, for example, that you want to use instead of Docker or Containerd or something like that, you could actually write Kubernetes CRI offers you a standard plugin interface that you have to adhere to be able to use their orchestration. So that, and you got CSI, which is the container storage interface, which enables multiple storage vendors to leverage the orchestration of the Kubernetes offers. So it's quite powerful actually, and it's one of the main reasons why they just growing and growing and growing. I'll give an example. Actually, at home I had my own little Kubernetes. I had Docker Compose, and I moved to Kubernetes because I had a challenge where I had to mount NFS onto all these pods, and I had a couple of probably a good 3 or 4 nodes, and I actually found it easier to move to Kubernetes because it had the CSI, container storage interface, for NFS. So that means I could point the storage directly to my NFS server, and I could share the storage that way across all the pods, instead of having to mount each NFS individually to that node and the pod and so on. But yeah, anyhow, that's a quick example there of the flexibility you get with Kubernetes. Scheduling capabilities. If you're looking for advanced scheduling capabilities, if you know that you don't need to scale up or scale down at certain times of the day or night, then you can do it with this. Or if you've got hardware requirements that you need certain workloads to land on, GPUs or non-GPUs, Kubernetes gives you the ability to really customize how you do that. Define, deploy, and manage your lifecycle in any way you see fit. But if you don't really care, then again, it's stay away from Kubernetes. And the last thing you should ask yourself, I think, from my point of view, is which cloud platform. If you're at the point where you know that you have to use Kubernetes and you now need to choose a platform, AWS, GCP, or Azure, your first point of choice should be to go with Google GCP, because it's an enterprise grade compliance, and it's a managed service for Kubernetes. It's a world-class security hardened environment, 0 downtime upgrades. It's probably your best and safest way to start your Kubernetes journey if you're at the point of choosing a cloud platform. But if not, if you're an AWS or an Azure, then, or specifically AWS, they have this thing called Fargate, AWS ECS Fargate for Kubernetes. Now that takes away the requirement to manage any servers, but it's quite limited. So you deploy your pods to a ECS Fargate serverless container runtime, but it's very limited. So you can't launch any daemon sets. You can't run anything containing privilege mode. So it's really quite limited. So if your workloads are really basic and simple, yeah, then use that. But other than that, yeah, you're quite limited into what you can do. Or just move to EKS. So on that note, I think that's probably at a high level of what you should be thinking about when considering Kubernetes. To dig deeper into the pros and cons, I'm going to hand you over to Nate, who's really got some highly opinionated views and love and hate with Kubernetes. So over to you, Nate.
Yeah, cool. Thanks, Marcelo. Yeah, I think it's really important to sort of break the fourth wall a bit and sort of be honest about our experiences and our sort of perspectives on Kubernetes. Sorry. So what I want to do is sort of have the real talk and talk about Kubernetes under the covers, and sort of address some of the common themes that I've had, speaking to clients, customers, coworkers, and etc. So I guess we'll start with that. And I think there's a very solid group of hot takes, I'd say, that I think that I've been hearing out there. Common ones include, why bother using Kubernetes? It's too hard. What else? It's too expensive. It's complete overkill. It's unnecessary overhead. For most workloads, there's next to no cost benefit. In general, not necessarily just Kubernetes, microservices is overrated. And I think something which is talked about a lot is that distributed systems are inherently flawed. And I think in terms of, absorbing all that and thinking about it, you're not wrong. I guess is probably the honest way to be about it. Kubernetes is not the tool for everything. I can say that pretty calmly and pretty confidently, and assert that although the benefits are really, really good when Kubernetes is the right tool, using a tool because it's a flashy new thing or people are talking about it probably works more against you than for you. And so I think to help you understand your mindset and to help frame your thinking, I think there's a few dot points or a few checkpoints that you could ask yourself. So understand that sometimes, and it's a good thing, sometimes Kubernetes isn't worth it. Again, bringing back what Marcelo said, if you have a simple, lightweight application that doesn't sort of benefit from really hyperscale or lots of distributed, high performing workloads, don't do it. It's not worth your investment of time. Secondly, if your culture, and this is a different one, people don't really talk about this too much. If your culture doesn't reflect the changes ahead that comes with building a big Kubernetes application, don't do it. And I think I'll qualify this by saying, so some people, on this cloud architecture journey, they usually vision it as, all right, we've got everything on-prem, it's a monolith right now. Eventually, we would like to get everything serverless, everything continuous, the most fancy and well-oiled application eventually. But realistically, you're not just quite there yet. And so some people view Kubernetes as a stepping stone between on-premises monolith and fully serverless, awesome application. Some would argue, and I think I fit in this case as well, it's probably a bad thing to force yourself into a Kubernetes because you're making your system less predictable by making it far more distributed while gaining little in terms of the architectural sort of progression. So assuming that the same people that are in charge of administering, your on-prem monolith or your pre-existing sort of legacy systems, containerizing it and pushing to Kubernetes won't necessarily solve those problems because the same people will be managing your Kubernetes clusters. I guess thirdly, if distributed computing isn't suited to your app, probably don't do it. And the main question that you can ask yourself to realize if distributed computing is good for you is, can your individual services, the individual services and workloads that you're going to split up, can they individually and sort of independently of the scaling and the requirements of the other services perform their functionality and deliver value? If the answer to that is no, then why introduce a potentially faulty network call to what would otherwise be a normal function call? And so, yeah, sometimes it isn't worth it, although there is more to be said about when it is worth it. Because Kubernetes is probably one of the more higher complexity platforms, applications, or frameworks, whatever you want to call it. But the benefit is there once you truly understand the problem. So I think there is more to be said about the true value of Kubernetes. So first things first, I think it's valuable for us, sort of as architects, developers, whatever, to decouple the thought of microservices from Kubernetes. If you just move on to the next slide there, Nate. He's fallen asleep. If you're going to do it, know why. Yeah. So if we sort of blob in all thinking about microservices with all thinking about Kubernetes, then all of our thinking about Kubernetes is weighed down by the shortcomings of microservices and vice versa. So if we allow our mind to separate the two, we can sort of define microservices independently and say, okay, well, microservices is an organizational scaling technique. When you have 500 developers working on one large application or one large website, it makes sense to pay the cost to largely scale and distribute that system if it means that you can split up your whole developer base into smaller teams and they can focus. You developed a sort of an organizational structure where you have smaller teams working independently and focusing on one particular thing and providing interfaces to other part of development or other parts of the business. On the contrary, where if you have 5 developers for a single application and you're splitting it into 20 different microservices, you're now getting quarter time for each microservice for each developer or maintainer, and you lose the benefit of distributed systems because there isn't the focus on there isn't the focus on the individual services, and you're pretty much in the same spot in a monolith where you're rushing to manage everything. And I think it's important to bring up Conway's law. I know some people in the room will know about Conway's law, but Conway's law stipulates that the software architecture, that's developed resembles the organizational structure that it was developed under. And so essentially, a hierarchical company produces a hierarchical system or application, and that just happens to be the most effective way to create a monolith. So go ahead with caution. Understand that Kubernetes is not a magic pill. It will not solve all your organizational problems, unfortunately. But if it's the right context and your culture and your company and your organization is willing to back it, it's great. A third point that I'd like to emphasize is that Kubernetes was truly built as a sysadmin tool for containerized workloads, meaning that, all right, containers are awesome. We haven't really talked much about the basics of containers, but basically you take your application, you smush it down into a small shippable workload that you can ship like a container to multi different workloads or hardware or cloud infrastructure, and expect it to run in the same way every time using the same definitions. Now, there becomes a problem when your application gets a bit more diverse or complex or distributed, and you need a way of orchestrating all of these different containers. I mean, as much as my job is configuring AWS consoles and Azure and GCE consoles, probably not the best use of my time. So Kubernetes was developed as a way using infrastructure as code to manage the distributed set of container workloads. So instead of being a single app and a single container, you've got multiple containers filling your application. And so the basic idea of Kubernetes was to further abstract away the machines, the storage, the networking away from the physical implementation. So it's a single interface to deploy to containers to all clouds, all virtual machines, all physical machines that support the runtime, and it's all defined as a singular infrastructure as code language. And I guess in that regard, Kubernetes is best thought of as being like a multi-machine operating system. Yeah, and so Kubernetes was truly designed to address particular needs in container workloads, i.e. horizontal scaling, automatic and manual scaling, replication and high availability, self-healing, traffic routing, load balancing, automated rollouts, automated rollbacks, and these sort of sysadmin tools. I mean, you could definitely achieve all these things with containers using other tools and possibly achieve the same outcome. But Kubernetes provides it all in one place with a single infrastructure as code language, and it's deployed to many clouds and computer architectures whilst maintaining your control of what's under the hood. And so I guess my sort of main theme, if I want you to sort of go away from this webinar and remember anything, is that Kubernetes is probably the best for mature applications with mature requirements. And okay, Nate, what do you mean by mature? So by mature, I mean the point in a project's lifecycle where you have stable development, test-driven processes, continuous everything, and rush jobs aren't really a reality. So you have the requirement for hyperscale. You have the requirement for really, really low mean time between failures and really low mean time to recovery. You have the requirement to be able to change things on the fly and have your infrastructure change with you. That is the main thing I would say. But I think from my perspective, those are all just words, and it makes more sense when you see it in context of the real world. So what I'll do is I'll hand over to Nathan, and he's going to outline some of the work we did with a multinational company here in Perth, and just it will really exemplify and show where the power of Kubernetes can come from and when it's used correctly. But anyway, thanks, Nathan.
Cheers, Nate. Yeah, really enjoyed that walkthrough, and I kind of want to take what you said last, where you've got a mature company with a mature workload, and talk about one of the other customers worked with Family Zone, a cyber safety company. They're based right here in Perth. So they were initially running workloads on AWS EC2, running apps just on boxes, no containers or anything yet. I'm going to take you through sort of high-level journey of what they were able to achieve, saving around 10% by migrating to GCP, and then saving a further 27% by utilizing containers in Kubernetes over the virtual machines. So it was a real success story, and there were a lot of parts of that were Kubernetes. So before we get into that, though, it's probably best to understand some of, I guess, their requirements that made them decide on Kubernetes. So I'll just go through the high level ones, and then we'll dig deep into each one. So to start off, their app needed to be containerized. They were receiving approximately 700 requests a second during peak period. They had a requirement for extremely low round trip latency. So I'm talking inter-service communication, sub 40 milliseconds, like real small. They had high performance Java application requirements that, had requirements on kernel level tweaks, which is something that you can't always achieve. Kubernetes can though. And the developer experience, they'd like to improve it. Right now they're dealing with VMs and they want to see if they can streamline that. So digging into the containerization portion, for those of you who haven't worked with Kubernetes or maybe haven't worked with containers, it's usually a really good step for organizations to start off with. If they have a mature application, maybe they're just running a Java app or Node app or something, best first step, just put it into a container. Like that immediately makes it kind of explainable because you can read through the container definition and articulate exactly what you need to make that app run. Therefore, you're making it repeatable so people can go through and rebuild that container from scratch and have the exact same environment every time. It's also portable, which is awesome because it means devs are able to run an environment that's similar to what's running or almost identical to what's running in prod on their local laptops while they're testing, which I think is a huge, huge deal. And if you haven't started looking at containerization, you're still running apps locally, definitely look at containers at the very least. So next we'll talk about how they were handling load. So a lot of people would probably ask the question, why not serverless? Like, why wouldn't you use something like Lambda for this? 700 requests a second, oh, seems like something Lambda could handle. So I suppose when this project was underway, provision concurrency wasn't a thing. Provision concurrency on AWS is where you can tell Lambda to always stay hot or ready for requests. So back then it was a lot harder to get consistent request times out of those Lambda functions, which is a really, really big deal, especially for this kind of app where you want those 99 percentiles, like they really count. And even now, like you need to have good understanding of request times between services. So if you're leveraging a bunch of services in a cloud, how do you make sure that you're measuring the request times between those services? There are obviously things to do that now, but back then it was less of a case. So again, handling those internal server requests was a pretty big deal. The lowest latency. So like I said, sub 40 millisecond round trip. I already iterated this a little already. But really needing to understand the response times between services. So if you've got 3 different microservices running and they're all talking to one another, how do you get the telemetry out to understand how those services are interacting and what speed they're able to respond in? So they needed observability, and we looked into Istio for that, which I'll get to a little bit later with a cool demo. But before that, let's talk about developer experience, because you've got a bunch of devs who are writing code and you've got potentially a bunch of ops people putting code onto boxes and shipping it. You want to shorten that trip. You want to make sure that like devs are able to deploy to prod. Like they should be able to push changes and push their code into prod, empower them to be able to push more changes. Means more smaller changes and less risks. So using Kubernetes was really great for this because it meant that devs were able to just define everything that they needed in YAML and have it just pushed out to clusters. So I'm talking attached disks, GPUs. If they need an API endpoint, a gateway to attach to their service, they could just do that. Define it in Kubernetes YAML, push it up to a repo, and have it all just set up for them. Like they don't need to log into a cloud console. They don't care what cloud they're on. You just do it. I think that's really cool. Like you've immediately set up the team to be able to unblock their own issues and get things out there faster. So that was a huge selling point for why we would go with Kubernetes. So let's talk about that service mesh that I mentioned before. So understanding how services talk to one another. When you're operating inside Kubernetes, everything operates on its own Kubernetes network. So everything is all inter-network communication is kind of a bit of a black box. So you'd install this thing called Istio. Now, Istio sits on each of your little containers. So if you have all your little containers and microservices, you have an Istio, I'll just call it Istio connector on the in and out of that service, and it measures things like, latency between service requests, number of failures. Can even pick up things like actually inspect the request. So it can go down into HTTP requests. So it's really cool. A lot of really neat little features. And this is a demo here of Kiali and how service mesh, you can visualize it. So I'm actually going to jump into a demo now because demos are fun. We have a website here, eks.mechanicalrock.io/product page. It might not work in Chrome. I didn't get the certificates fixed in time. That's my bad, but I'm just going to switch over screens and let's do a demo. Give me 1 sec to find the sharing box. Sorry. Cool. Can everybody see, or actually my fellow presenters, can you see that?
Yep.
That's cool. So here is Kiali. This is a visualization tool on top of Istio. The really fun stuff is graphs, and this is the web app that we're monitoring here. So let's go ahead and refresh this page a couple times. As you can see, book reviews sort of trickle through. That's really neat. You know, you get different book reviews, and every time you're getting a different book review, it's actually hitting a different API endpoint. So if we go back to Kiali webpage, you suddenly see this mesh sort of changes. That's because we're able to see the traffic going all the way through the system, hitting the API version 1 and splitting off into 2 microservices. These version tags indicate different versions of the service. So as you can see there, there's 2 different versions of the API endpoint were hit. So you actually get to see the split traffic there. So I'm going to try something else. We can go and type in admin, refresh that a couple times, log out, sign in again. Just trying to hit some different endpoints. Hopefully this demo works. If it doesn't, we'll go on. But the idea is that you're able to pretty much view all the traffic through the network and isolate and work out what problems might be occurring. So another really good thing about, I guess, this visualization tool is you get the indication of like traffic HTTP requests and if they're successful or failing. Under the actual workloads themselves, you can get you can get inbound metrics. So these are all stored in Prometheus and available through Grafana as well. So you're able to basically view statistics on the different services and their versions straight through one dashboard, which I think is really cool, really, really easy to quickly understand what's going wrong in your application, and something that I'm very, very fond of. So I actually had a question here before I jump on, asking me, what are your thoughts on Kubernetes at the edge, like K3OS and KubeEdge? So that's an interesting question. I've actually never tried KubeEdge. I've talked to people who have used it though. I think it has a interesting place, but I would be asking questions about what you're actually running at the edge before recommending using Kubernetes at the edge. If you're running a lot of different microservices at the edge, as Marcelo was saying, you had a really complex, mature workload, maybe Kubernetes at the edge is good for you. But maybe if you're just running one container or a few services, you could settle with something like Greengrass and actually just run those as functions at the edge. Like, it'd be cool to understand what you're actually trying to do and how much, I guess, baggage you're already dealing with before looking at some of those solutions, I'd say. And with that, I might jump back over to Marcelo and let him talk about CI/CD in the Kubernetes world, if that sounds good.
Sounds like a plan. Pretty cool demo.
Thanks.
It was a bit like a cat watching a light on the wall. Good.
That is useful.
Yeah. Okay, so you have a Kubernetes cluster that you want to deploy to the cloud, and I think the best approach to do that with least admin overhead is adopt like the DevOps as well, with a GitOps way of managing your code. So having a single source of truth for your declarative infrastructure and application source is probably the best way to go to allow fast iterative development cycles, as well as simplify your maintenance. So here you have a diagram of the whole workflow from start to finish. So in this case, we have GitHub as a source version control. We have Cloud Builder as our CI tool, which is the GCP tool in this case, but it can be AWS or Azure equivalent. We have container registry, which is Google's container GCR. We're using Argo as the Argo CD, which is a declarative GitOps continuous delivery tool for Kubernetes, coupled with Kustomize, which is your, I guess, Kubernetes native configuration management tool. So all these are married nicely together to give you a really cool, slick workflow in maintaining your applications running on Kubernetes cluster in the cloud. So to start with, I think we have, as an example, we've got 2 applications and each in their own repo, and we've got a third repo, which is your infrastructure repo, which is essentially, it's good to have separate away from your main application source. But all that essentially is your shared services, so stuff like your VPC, your networking definitions, any shared databases, any data warehouses or anything like that. Your Kubernetes cluster, you define as code. So everything's as code here. So in this case, if it's Terraform, CloudFormation, being the 2 main ones to go to, that's where all that code will be. And in the other 2 application repos, we have say, for example, application 1, the application 1 underscore source is just essentially your application source, and app1 underscore KRS underscore manifest is where all your application, all your Kubernetes manifest specific to the application, like your deployment, workloads, your pods, services, ingress, any of that kind of stuff specific to that application are in that directory. So you start with your CI starts, does unit tests, it builds your Docker image, tags it, pushes it to the registry, and the next step after that, which is where customize kicks in, it actually updates the manifest directory with the latest commit hash to the Docker image, so which has just been you've just tagged and pushed to the registry. Now the thing to note here is Argo is only monitoring the manifest directory, so it's only going to wake up once an update to that manifest directory has been made, not your source code. So once Argo picks up the change, it'll deploy those changes to your application in the Kubernetes cluster. Now, I think to keep in mind here, what Argo does, it automatically or manually syncs the live state back to the desired target state of your application. So if someone does any changes through the console on your application, Argo said it will pick that up and revert it back to what is defined as code in the source repository in GitHub in this case. So that's really cool. So you shouldn't be doing anything in console. Everything should be as code. It's just easier to manage and trace back any changes or fix any issues. So that's really start to finish how you should be deploying your Kubernetes workloads. There may be some slight changes if you want to separate your application source and the Kubernetes manifest. But with Argo, then you probably find that you have to do some trickery in order to sync how you update that as well. So, but it is doable. But this is probably your easiest one to manage, and yeah, it just seems to run a bit easier. So yeah, there you have it. So the next thing we'll move on to now is answering any other questions that we have from anyone out there. Let's have a look.
We had a question here asking us, for a complete noob, where should we start, or where should people start if they're I guess a total noob, self-proclaimed noob to Kubernetes? Does one of you want to answer that, or I'm happy to?
I can give a quick overview on that. So I think before there was a really high level of knowledge required to gain entrance into Kubernetes. So you really need to know containers, your Linux, a strong sysadmin background. But these days, I mean, Kubernetes has matured enough to make it a lot easier for people to start with. With the kubeadm tool, you can build a cluster, within 3 to 5 commands, and onto your own virtual machines, or a couple of virtual machines on the cloud, and it's just a lot easier to get started. So there's Kubernetes the hard way. You don't have to do it that way, but yeah, so it's a lot easier now these days to get started if you just follow the kubeadm way. And there's some good docs on kubernetes.io, but start with a small app. Yeah,
definitely don't use Kubernetes the hard way. Is great if you need to learn for an exam, but if you're a beginner, don't do it. Go to a cloud provider and ask for a cluster. Just spin one up, spin it down after you're done, and play around, because it's much easier that way.
Yeah, there's definitely a lot of complexity to be found in Kubernetes. You don't have to find it on day one. Just start as easy as possible.
So we've got a good question from Dinesh, and his question is, building out a Kubernetes infrastructure, is it best to build from scratch or use tools like Gravity or Rancher? I'll probably take a step back and actually really understand your business requirement and logic, after which then you map your application onto that business requirement, so application architecture. And once you have that kind of sorted out, it's easier to write your manifest, the Kubernetes, you containerize all your applications, and sometimes when you start engaging all these other tools, it could complicate the whole environment. So writing them from scratch, I think, on your own. There's even the Kubernetes operators. I mean, a bunch of Kubernetes operators out there now, which can simplify how you write or how you build your infrastructure. So I'm probably against introducing too many tools like that, Gravity or Rancher. Although the Rancher is quite popular out there, but I'd probably use them as a last resort, to be honest.
We had another question here around the best storage backend for DB workloads, and I guess I'd answer that as again, I'd come back to like, what are you looking to run DBs on your cluster, or are you looking to run them in the cloud? Because where possible, you should probably preference trying to, if you are running a cluster on cloud, for example, I would be trying to leverage database solutions as managed services rather than running a database in your cluster, unless you have a very good reason to do so. Because obviously, if you're running a DB in cluster, you need to deal with things like upgrades. You need to deal with having volumes that don't magically disappear. So you sort of need to do what you know you're doing a little bit more if you're dealing with databases on Kubernetes. However, if you're talking about storage backends, I probably can't speak to that. Do any of you guys have more?
That's an interesting question. That's probably the pain point of a lot of people out there. Is the main driver is cost, I think, here is, so if you don't want to use a managed service database backend from the cloud platform because it costs a lot, so you think you're better off deploying your own DB workload as a Kubernetes deployment. We've seen a lot of pain in doing that, especially, I guess it depends on the database, but most recently with like MongoDB, I mean, that was a massive fight. And a lot of challenges when we tried to do that. So really think about your budget. But it's worth paying if you have the budget to use a managed service for your database workloads, because what you find is if you roll your own infrastructure for it in Kubernetes, you're going to deal with having to work out your scaling requirements. You need to have someone with a high level of database knowledge, DBA, as well, to manage that as well. So you're taking away your focus on developing and improving the application, then you start building up a team of DBA experts or DB experts, which you don't really want. But it's a common issue a lot of people have as well, just to help save costs. But sometimes it's not worth it.
So we got another question here. Did you find you had any issues with testing new versions of applications when going through deployments? And I guess you guys could probably talk to the specifics of your application work that you did with Family Zone, right?
That's an interesting question. I don't know what level they want the answer to, though, but I could say, like, in terms of how you actually deploy to Kubernetes, as long as you've got like I guess good health checks, so you can set health checks on I guess pod deployments. You can tell it, you need to be healthy and ready within this time frame. So at the very least, having that stuff set up is super easy, because it means you can quickly smoke test the apps that get deployed to make sure that like they don't like roll down the previous version before bringing the new one up. So at its basic, like whenever we ran into problems with apps that crashed randomly and stuff like that, we'd always find the case that the original app was running still before getting cut over. So, but in terms of like the more detailed testing, we didn't really get too much into that. Do you think of anything, Marcelo? Or
Not really. I mean, it just comes down to, it varies from place to place and what kind of integration tests, if you have any, or unit tests you have for your application, how complex or simple they can be. If you want to have your end-to-end testing before deploying, you set up your different environments, your staging, your production, to control how if it was a fix or if it broke your deployment, for example. But that's probably,
and like
that's what it,
another feature of Istio that we didn't look too much into for this, but you can do traffic splitting for versions too. So you can say 10% of your traffic goes down one path, and you can monitor issues on that particular path. So you have a lot of options with some of the tools on the marketplace, out there. Like those aren't really part of the core Kubernetes. You can do split deployments as part of core Kubernetes, but leveraging stuff like Istio, I hate telling people to go look at Istio unless you have a real reason to do so. But if you really, really wanted to do some proper deep testing and split tests, that could be an option.
Cool.
Yeah, I'll add in. And depending on sort of the complexity of your testing framework, because Kubernetes does come sort of in the box per se with automatic rollouts and automatic rollbacks, which you can utilize as part of your testing framework to do that. But that's sort of a big assumption that you have that sorted out. But yeah, another question. When it comes to security and Kate, what areas have proved to be pain points in your experience? From my experience, if you are manually configuring role-based access control to multiple clusters, it can be a bit of a pain point. What do you guys reckon?
For us, it is probably role-based access if you're dealing with clouds. So when you have cloud services and you want to give like service roles to pods within a cluster, you'll see a lot of setups where people will create security tokens, inject them into Kubernetes secrets, and then sort of mount them onto pods as service roles. There is like a new feature called workload identities on GKE for this that is supposed to make it easy. But I guess for me personally, like I had a lot of issues trying to come up with a nice way to do like the management of what pod can access what service based on cloud-based roles. I still think there's a little bit of work that needs to be done to sort of take that Kubernetes cluster that's sitting in a cloud and properly integrate it with IAM or RBAC within your cloud's IAM. If that's what you mean by security, that was a big pain point for us. So
yeah, spot on. The other thing I've noticed as well is when it comes to implementing good security practices, you need some more knowledge about networking as well. So if you want to implement borders around specific deployments or workloads, then with Kubernetes you got your network policies as well you can apply. You got to really understand all your ingress and egress traffic, what's going on and what ports. So having a really strong sysadmin knowledge of the underlying infrastructure will help there. So it is somewhere where a lot of people kind of don't think too much about, and they kind of rely on the platform, IAM roles to deal with that. But with Kubernetes, you actually have to give it a lot more thought than that, because it is quite powerful and you can do a lot of stuff, so you're more open to security vulnerabilities in that sense. Now, another thing to make sure you have is your container scanning. On pushing to your registry, make sure you have your CVs up to date, whatever tool you're using, if it's the cloud one that they're offering, or something like Sneak, SNYK, which kind of does that for you. A bit more proactive in terms of scanning your containers and applications for any security vulnerabilities. I can't even say that word today. But, yeah. All right.
Yeah. One thing, sorry, I'll piggyback off that one real quickly. So Kubernetes provides you with tools sort of to implement your security strategy. So, service roles and, all the tools you need to actually, implement your security context and boundaries. But it's really important that you have those defined before, because what I found difficulty with is that if I don't have a clear understanding of the security context which my application is working within and the boundaries that need to be put in place, it's got to be really hard to define that. So I think before you even start, implementing your security strategy within the tool itself, is to think about what you're trying to achieve.
Cool. All right. One just came in by Jason. Okay, someone want to answer this last one, quick one. Why Git? What if we want to use a Subversion instead? Can I call it Subversion Ops? Someone's taking the Mickey, or maybe someone.
I prefer that over GitHubs. Like, I don't know, it's got a ring to it.
Yeah. Got a bit of a Klaus ring to it, I think. All right. Let's wrap it up now. Okay, first of all, to wrap up. So after all that, I hope we've helped you realize the power of Kubernetes, and with that comes a lot, great responsibility. So it can either become an over-engineered option for yourself or for your whole container orchestration environment. So do think long and hard about before jumping on the Kubernetes bandwagon. It's not the answer to everything, like Nate has said. But on your flip side, Kubernetes is not showing any signs of slowing down. So it's fastly propagating itself through many different software platforms out there, different verticals as well. No matter where you'll be working in. So it is still maturing at a really fast rate. But yeah, so it can only get better. So thanks for joining us again, and just keep in mind that Mechanical Rock have been inducted into. We're now CNCF, Cloud Computing, Cloud Native Computing Foundation's member now. So where we also have achieved the status of becoming a certified Kubernetes service provider, now sanctioned by the CNCF. One of the Perth's local WA companies to achieve that, with all the talent being local. That being the three of us here, and many more in Mechanical Rock. So if you have any product that needs to go cloud native with Kubernetes as your platform, you know where to go. And yeah, also don't forget to join the biggest conference, Latency, about all things cloud native. The link's on the page there, so you can get some more information. So again, thanks again everyone for joining us, and yeah, hope you can contain yourself.
Cheers, everybody.
Thanks for attending.